Everyone, how do you solve this equation? X to the X to the X to the X to the X, and so on infinitely. X raised to the power of itself infinitely many times equals 4. What is the value of X? You can't just guess this, right? 1 doesn't work, 2 doesn't work, nothing works. So how do you solve it? When you encounter a problem like this, it's called an infinite nesting problem or an infinite recursion problem. So how do you solve this kind of problem? The first step is to set the whole thing equal to t. Then, do you notice something? From here upward, isn't it also equal to t? It's equal to itself. That is, x to the power of t, this whole chunk is also equal to 4. And this whole chunk, didn't you just set it equal to t? So t equals 4, right? Isn't that the logic? This whole chunk is t and t equals 4, right? From here, it's also t. So isn't x to the power of t equal to 4? T equals 4. So doesn't that mean x to the 4th power equals 4? So what is x? The 4th root of 4. What's the 4th root of 4? Take the square root twice. First you get 2, then take the square root again, and you get the square root of 2. Everyone, try plugging in the square root of 2 and see if it works. The square root of 2 to the power of the square root of 2 to the power of the square root of 2, and so on. Does that equal 4? Try it out later and see if it equals 4. If that's hard to verify, let's try another method. This whole chunk is equal to 4, right? So this whole chunk is also equal to 4. That means x to the 4th power equals 4. And from this chunk, it's also 4. So x to the 4th power also equals 4. Everyone, from this chunk, it's also 4. Now try plugging in the square root of 2. The square root of 2 to the power of the square root of 2 to the 4th power. Doesn't that give you 2? The square root of 2 to the 4th power is 4, right? So doesn't that equal 4? There's no problem. Plugging in the square root of 2 works fine. Try it yourself. Give it a try.